So let us start discussing the problems regarding chemical kinetics in enrichment class. We have been discussing about electrochemistry, but since our regular CBSE curriculum has allowed us to discuss about chemical kinetics, so here in the enrichment class also we are going to discuss about chemical kinetics. So straight away I have chosen the ALP, that means the advanced level problem, because of the fact that we are already solving the regular problems in the, or the, you can say the board level problems in the regular classes. So why not solving advanced level problem? Let us see how difficult these are. As I have said, the problems, the pattern of problems will be different compared to the NCERTs. So let's see. First problem straight away looks like this. For the complex Ag plus 2NH3 in an equilibrium with the product, that is Ag NH3 whole 2 plus. This will be formed. Now this is called a complex, this one. It's a coordination compound having a coordination bond between the silver and the ammonia. Now what is that? We are going to discuss about it in the coordination chapter in class 12 itself. But as of now, just remember that it is a coordination complex. The coordinated bonds are there. Now it is given dx by dt is equal to 2 into 10 to the power 7 liter square mole to the power minus 2 second inverse Ag plus NH3 whole 2 minus 1 into 10 to the power minus 2 second inverse Ag NH3 whole 2 plus. So this is given. You must be little bit amazed to see what is this basically, but this is just a expression of the kinetics, how the reaction is going to propagate. We are going to utilize this kinetics. The question is, hence the ratio of forward and backward reaction, forward and backward reaction is. There are options. I am not writing down the options because if the options are given, the problems will be easier because it gives us the chance to back calculate. So without having the options, let us see whether we are in a position to solve it or not. So carefully read it once again. As per the question, a complex is being formed. It is in equilibrium, right? Remember, at equilibrium, what happens is, at equilibrium, the change in the rate, or you can say the change in the concentration of a reactant with time becomes 0. So we should be writing dx by dt is equal to 0. Now if it becomes 0, so this total part becomes equal to 0. So we are going to equate that only. So we are writing 2 into 10 to the power 7. I'm just not writing the units, not required in the calculation. Ag plus NH3 whole 2 minus 1 into 10 to the power minus 2 Ag NH3 to equal to 0. Now further to calculate, what we can do is I'm keeping the concentration terms on one side. So I'm taking, this is on opposite side. So I'm rewriting 2 into 10 to the power 7 Ag plus NH3 whole 2 is equal to 1 into 10 to the power minus 2 Ag NH3 2 plus. Now check over here, since this is on the product side, so according to the equilibrium, this one should be above and this one should be below. So I am maintaining that only, the concentration of the product should be above. So I am keeping these terms on this side and this 1 into 10 to the power minus 2 onto the opposite side. So rewriting, I can obtain Ag NH3 whole 2 plus divided by Ag plus NH3 whole 2 is equal to, see, this I am taking on opposite side, so it should become 2 into 10 to the power 7 divided by 1 into 10 to the power minus 2. So it is obvious that, now you see the units, it was having liter square mole to the power minus 2 second inverse, like liter square, just a calculation on side by side, mole to the power minus 2 second inverse divided by second inverse only. So this and that will cancel out. It becomes liter to the power 2 mole to the power minus 2. So now you can write, it becomes 2 into 10 to the power minus 9, sorry, 10 to the power 9 only, because this is negative, and the unit will be liter square mole to the power minus 2. So we have got the desired answer now. Now let us look into the next problem. The next problem also based on similar concept but not exactly same. The second one for today is in the reaction, just erasing this part so we can utilize the full whiteboard. Second one is in the reaction N2 plus 3H2 giving rise to 2NH3. It is given dx by dt. I hope you have understood what they are suggesting. 1 into 10 to the power 2 is N2 H2 cube minus 1 into 10 to the power minus 3 NH3 square. Alongside it is written, and at some instant, if N2 H2 divided by NH3 whole 2 is equal to 0, sorry, is equal to 10 to the power minus 5, this one, then at this instant the value dx by dt is how much? That is the question. Options are given. In this case I am writing the option because it will be required. 1 into 10 to the power 5, C is 1 into 10 to the power minus 5, D 1 into 10 to the power minus 3. We have already seen a problem, similar problem like this before. It is an equilibrium case, right? It's an equilibrium case, and then it is asked what should be the value of dx by dt if the reactant by product is given. You can see on the right hand side, the reactants by product is given as 10 to the power minus 5. Now what I am going to do is, I am going to rewrite this. So I am going to rewrite dx by dt is equal to 1 into 10 to the power 2 into h2 whole thrice minus 1 into 10 to the power minus 3 nh3 whole 2. Since an equilibrium symbol is given, and carefully you see, check this part, is not it the same? Check this part, same thing. So if I take dx by dt is equal to 0, if, so just I am trying the first option, if I take dx by dt is equal to 0, what happens is 1 into 10 to the power 2 into h2 whole cube minus 1 into 10 to the power minus 3 nh3 whole square is equal to 0. Now my target is to check this by that. So I will keep this as it is. So I am taking this part on the opposite side. So just rewriting, it should be 1 into 10 to the power 2 into h2 whole cube is equal to 1 into 10 to the power minus 3 nh3 whole square. Rewriting, check here, if I keep into h2 whole cube divided by this nh3 whole square. Now I am getting the same as this. On the right hand side, it is 1 into 10 to the power minus 3 divided by 1 into 10 to the power 2, which is, you see, 1 into 10 to the power minus 5. See this value. See this value now. Same. So I am getting the same value as this one. But at which condition? The condition is this one. dx by dt is equal to 0. So the first option is correct. An absolutely different type of problem, but I have started solving these two problems so that it will give you a new dimension to think about this type of equilibrium related problems, although it is the chemical kinetics. It comes in the chemical kinetics chapter. Now the third problem, the question is, for the non-equilibrium process, A plus B giving rise to products, the rate is first order with respect to A. Rate is first order with respect to A, and second order with respect to B. If 1.0 mole each of A and B is introduced into 1 liter vessel, and the initial rate was 1.0 into 10 to the power minus 2 mole per liter per second. then what will be the rate? What will be the rate when half reactants have been turned into product? Half reactants have been turned into product. Options are given, I am not writing. So I would ask you to go through this once again. It's a non-equilibrium process, first thing first. First order with respect to A, second order with respect to B. So straight away I can write R is equal to K into first order with respect to A, second order with respect to B. First thing first, for concentration of A, initially it is 1 mole per liter, right? And the same will be the concentration of B. Check here, 1 mole introduced into 1 liter vessel. Makes our job easier. So according to that, the rate is given as 1.0 into 10 to the power minus 2 is equal to K into, here it is 1 and here it is 1 square. Our target, what is our target? Our target will be initially to find out the value of K. So K from here will be 1.0 into 10 to the power minus 2 only, right? And throughout the reaction, this value is a constant value. So for the second case, where it is asked what will be the rate when half reactants have been turned into products, that means for second case, the concentration of A should be half mole per liter and concentration of B also should be half mole per liter. So for the second case, I should be writing R is equal to K into A B square. K is now constant 1.0 into 10 to the power minus 2. Here it is, the value of A. The value of A should be half and value of B should also be half and the square of it. Now if you calculate the rate, you will be getting as 1.25 into 10 to the power minus 3. So this is how this type of problem should be solved. Looking at the first data, we have calculated the value of K, which is constant. Remember, in the second case also, we can directly put the value of K because R is asked now and A is halved. So accordingly, we have calculated the rate. So today, this type of problems are completely different to the problems that we have solved in the regular classes. Carefully see to it.